All right. Welcome everyone. Today I want to talk to you about a project that we did here at Make It Fly a few months ago, where we chose to use Flutter as our solution to create real-time bus displays for the new shuttle buses that tour the city center of Bruges. First of all, this is just going to be like a story today. So I'll give a brief introduction. I'll set up the story a bit to get everyone in the mood of the tale. Then we'll go to some technical stuff. There is going to be like a couple of interesting stuff in between, hopefully. We'll have an exciting twist near the end, and then hopefully the story will come to a happy end. But first of all, I'm going to introduce myself. So my name is Fré. I was a developer at Make It Fly. I actually gave this talk already in Prague at F3. And since then, something changed. I actually went on a different path. Freelancer right now. I live here in the city of Bruges, where this project takes place as well. And if there's anything I can say, I'm just a Flutter enthusiast. So, let me first tell about about these shuttle buses that we have right now in Bruges. Maybe some of you saw them drive by here. Nobody? Somebody? You did? Perfect. So what actually happened, as you all are aware of, a lot of things are changing in mobility these days. I think near the summer, the lane decided to completely overthrow like their current schedules and change everything. And with that, there was a possibility for the city of Bruges to improve their mobility as well. So they checked how they could make transportation within the center of the city a lot better. And they sat down together with the lane and decided to only have a few buses from the lane pass through the city center. Now, to accommodate other people living in the center and still get everywhere, they chose to have their own free shuttle buses that continuously tour the city. For this, they partnered up with Keolis. Keolis is a worldwide mobility provider. And at that point, they were already a client of Make It Fly for several types of projects. And then they came to us with a question, because to do this project, they needed to have onboard displays that show which stops are going to be next. And they didn't have anything ready yet. So when they came here, they actually came here for a different project to talk about that as well. And then he mentioned, yeah, we actually have this contract with the city. We need to have some sort of solution there. Can you help us? And we were like, yeah, this is something cool. This is something interesting. It's something different than a normal app or a website. Yeah, we're definitely fan of that. And we asked, like, okay, when should this be ready? And I don't know if this is an exact quote, but this is what I remember. So basically, we only had about 2 weeks to get this done. Eventually, as a side note, there was some more time because there were some other hiccups in the delivery of the buses and so on, so it gave us a little bit more space. But we dove into this project with this in mind, that we only had limited time to deliver the product to the client. So I've been talking a lot about it. Let me first quickly show what it is. So in these little buses that tour the city, they have these displays. They're quite simple, but they explain just at which stop they are, which is going to be the next stop, and so on. Here's a small visualization of where these buses go. Since beginning of this month, it takes a little bit larger course. And yeah?
Side question.
Yeah?
Because I depend on public transportation.
Okay.
You mean that in all the center of Bruges,
Yeah.
this is the only thing to move around?
No, there's two other buses of the lane that are going through the center, and there you can easily switch off to those shuttle buses if you need to get somewhere specific. They actually decided to have less of the big buses of the lane going through the center, because before it was all of them basically, which is quite like disturbing and making a lot of noise within these small streets that have these cobblestones and everything. So they want to make it better like this. I have a short video, but I didn't test the audio. The thing is, there's a small spoken announcement as well every time they're leaving a bus stop again. So with this project, of course, there were a few challenges that came to be. First of all, we had to provide real-time data. It has to be updated when the driver leaves a stop, when it starts again, when it stops at a certain bus stop. Another challenge were these announcements that have to be made. So also for the visually impaired passengers, they have to know which stop is coming up. And of course, to make it scale, we wanted to have over-the-air updates. Even though that they pass by the office, it shouldn't be the case that we have to get on board and fix stuff, which may or not happen a few times. But when thinking more about this, definitely the state of the city with these cobblestones, we also had some physical challenges for this, because you cannot just put any type of device in there. And when we started the project, we didn't know what we were going to run on. We didn't know the platform. Was it going to be Android? Was it going to be maybe an Android TV that is going to support this? Maybe, who knows? But is it going to be strong enough to hold these physical challenges? Another common solution for this is using a web-based solution. There are several providers of these displays that use web. Others use Windows or Linux. But at that point, we just didn't know. We could have gone for an embedded solution as well, but we didn't know, so we just chose Flutter, because we could defer the choice of which platform to run on. Meanwhile, we could start building already. So we also came up with some hardware solutions for all of these challenges. Eventually, we chose to go with an industry standard screen that is seen in a lot of buses and trains and all these types of transportation systems. I don't remember the name exactly, but it was their main business. For the audio, we decided just to use the audio of the bus, because these monitors that these companies provide, they just care about visualizing stuff. They don't care about having a sound system in there. So we just said, okay, what if we just use the onboard radio? And we checked, could we have something with an audio jack? And this should have been not displayed yet to keep it as a surprise, but we went with the Raspberry Pi.
Did you go with the CM version or the normal version?
I think just...
The one in the picture or the one that...
Yeah, we went with this one just to be sure. We actually went for Raspberry Pi Model B, the fourth generation of it, with way too much RAM, because we just didn't want to risk it. We only had 2 weeks. But the Raspberry provides all the necessary connections that you need. It's relatively cheap. It can easily be tucked away somewhere. And you can run multiple types of operating systems on it. So even then, choosing this hardware, we were still flexible in which type of platform we want to support with Flutter. So I think we had a few solutions that we thought of, and one of them is to use Flutter for embedded devices. But at the moment, it's still in a very early stage. Even if you read the documentation about embedded Flutter, it says that just like this line here is not for beginners. It's just they don't have a simple solution yet because you have to work with low-level APIs. And if you only have a short time frame, this is not something that we wanted to dive into at the moment. If you are interested in using Flutter on embedded devices, you can check out these community solutions that offer custom embedders that work on the Raspberry Pi. But a side effect of that might be that you also won't have a lot of plugin support. You can use packages and so on, but maybe not all types of plugins are supported. Then another solution that I was thinking was, okay, can we use just Flutter on a Raspberry Pi that is just running Linux? Because Flutter is completely available for Linux for desktop. But it is still quite tedious to set up. I thought until this morning when this article came out, which actually gives a video of how you can connect your Raspberry Pi to your development machine and just run directly on the Raspberry Pi. How this actually works is it's just using the Raspberry Pi OS, which was previously known as Raspbian, which is just a Debian distribution. It runs that on the Raspberry Pi and runs Linux Flutter apps on there. This is actually done by a company called Snap Embedded. Maybe for the people that were at FlutterCon in Berlin and saw the talk about making coffee with Flutter of Moritz Thijs. This is his company. He is focused on just making Flutter a lot more easier for embedded devices or any type of other devices. And with this, you can actually just use hot reload, you can use the dev tools. It would just be like developing on a mobile device. But then we were looking for still another solution. So using Flutter on Linux on the Raspberry Pi was tedious at that time. And when I was looking which type of operating system I could install on the Raspberry Pi, I just went through a list and my eye fell on this one called Full Page OS. You can probably guess what it does already. It's just a distribution that opens up a Chromium browser the minute it starts up. You configure it with the URL it has to fetch, and you give it some network configuration so it knows which Wi-Fi to connect to and so on. And then it just does that. So eventually we chose to go with this and chose to build Flutter for the web. Definitely check it out. It's a super useful package if you just want to create a simple kiosk application. But the web still has some issues. Has some people of you already developed with Flutter for web? We have a few hands, nobody super convinced. And I agree. It is very nice to have that option, but it can be tedious to develop in it. And definitely the case around hot reload. Hot reload is not working on Flutter for web at this moment. So you can only use hot restart, so every change that you push takes you back to the beginning of your app. And if you have complex apps, you have to go through the whole process again just to make the small UI change. Luckily for us, it didn't matter, because this is just a one-pager and it doesn't manage its own state. It fetches it from somewhere else and listens to the stream of new data coming in. So we didn't have this problem. This didn't hold us back. But if somebody wants to develop something for Flutter for web, it might be good just to try to develop on desktop, even if you're not going to publish on a desktop application, because it just gives you a large screen and you can just easily use the advantages of hot reload, and then eventually run it on web, see if there's still any difficulties, and solve it that way. I think it will boost up your development speed a lot. There's some other issues that you might have. Playing audio is not as easy as you might think, and definitely not in a browser these days, because Chrome and Chromium, they require you to interact with a page before it can automatically play any type of media. The problem is these are just these screens hanging there somewhere. We cannot ask the passengers like, yeah, tap it first and then it's gonna be fine. But luckily, there's an option in Chromium. You can just say, okay, do the autoplay policy to no user gesture required, and then it's all working fine. Unfortunately, this was not available in full page OS at that time. And at this point, I was thinking like, okay, should we move to another platform? Should we go for Linux apps? Because we can still move. It doesn't matter yet. And I came to look back the next day, and I don't know, this was kind of a miracle to me, but somebody submitted a pull request on the next day to address this issue, which was probably there for months already. So there was a fix, and even by the time that we had to move to production, it was already available in the nightly builds of full page OS. So we were able to use that and not spend any more time thinking about how to play this audio. Now we have everything set up, but where do we get the data from? Because these buses are driving around the city, they need to know where they are, they need to know how to update the data. And back in 2019, I think, we started on the development of KeoCount. KeoCount is another product that we made for Keolis, which is actually an assistant app for a driver. It shows the next stops and when they have to leave those stops and so on. And they initially made this for collecting some data about which types of passengers get on and off which types of bus stops. So it was mainly focused around collecting events about the routes these buses take, so that they could optimize it. Now, other than events like a passenger got on and off the bus, they also collected the events of the bus started driving, the driver arrived at a stop, they leave the stop again, and so on. So we were able to use those triggers to update our screens. Now we got lucky also because these events were actually never made to be sent in real time. But on Android, if you have an internet connection and it was powered to a power supply, it would actually just upload all these batched events immediately, and it only took about 2 seconds for an event to actually reach the server, which was fast enough in our case. We also provided these tablets with SIM cards, so they would have this constant internet connection. Now everything, I explained a lot of different components. I'm gonna show them all in a scheme together just after this. I want to talk about how we use Firebase for this. I think most of you all know that Firebase and Flutter are a match made in heaven, if I can say it like that. It just works super easy to get it something started. And for this project, we chose to use Firebase hosting just to host the web application that is running on the screens. It was very easy. They provide you with a URL that we didn't actually have to change because it's hidden anyway. So we could use that. We didn't have to go to DNS configurations and so on. Again, this is all had to be done in 2 weeks, so we didn't have a lot of flexibility there. And if we're talking about real-time data with Firebase, of course, we're thinking about Firestore. So Firestore kept all the data of each bus that needs to be tracked, so it can just listen to those new updates. And the last product that we use or cloud functions. Cloud functions in Firebase allow you to easily create HTTP endpoints as well, which made it a lot easier to update the state of Firestore there than doing that in the backend that we already have. Our backends were written in PHP, which doesn't have official Firebase SDKs. There are some community solutions, but we didn't want to dive into those at the time because of the time constraints. So putting this all together, because I explained a lot of different systems, when it actually starts, when the bus gets its power, the Raspberry boots up, it connects to the Wi-Fi that the tablet is actually emitting through a hotspot. Then it goes to fetch the web application. It shows that one on the screen. It then goes to Firestore, because in the URL that we predefined on that specific Raspberry Pi is also an identifier of that bus. We just use the license plate number. It's an easy identifier, and like that, it gets streamed updates about where this bus actually is. Every time it gets an update, we update the screen. And then when the driver uses his assistant app that was sitting there, these events get transmitted to the backend. And at the backend, we just send a state update towards Cloud Functions. Cloud Functions updated the Firestore for that specific bus, goes back to the Raspberry Pi, goes on the screen, and eventually gives an announcement which stop is going to be addressed next. So this is how everything came to work out, where we worked with existing components such as the Kio Count app and just tried to get something up and running. So, and it was working. Hooray! Just to give an idea, I think this was after about a week of development. So we just put all the pieces together, and it worked, and we were happy because it worked at the office. And I think that's where we get into the second part, which was actually the last week. There was some time in between, but the buses still needed to be assembled. They needed to come to the city of Bruges, because I think it were Turkish buses with German engines assembled in France that had to be used here. So it's a whole thing. And eventually, this was the last week of June. On Tuesday, the buses arrived, and we were able to go there and install the Raspberry Pis. And I remember going there. We got on the bus. We checked, like they nicely put all the necessary connections together. So I hooked them up, and we tried out, and we don't see anything. And I'm curious, like, okay, is the electricity on? Yeah, everything else seems to be working. And so yeah, we're trying to figure out this problem. And as a developer, I thought, like, yeah, maybe it's this bus. So let's go to the other bus with the other Raspberry Pi. And meanwhile, on the first bus, they're calling the people in France, like saying, like, yeah, is something wrong here? What's going on? And I go to the other bus. I take the power cord. I put it in the Raspberry Pi, and I'm like, oh yeah, it works. There's a light here, and smoke. And that's when we realized that they actually hooked up the power cords to 12 volt instead of 5 volt, which completely fried the Raspberry Pis in the week that we had to ship. So that became quite exciting, but we were able to order new ones, which isn't always that easy to get Raspberry Pis delivered fast enough. In the meanwhile, they fixed this problem. The Thursday evening, we went back, installed them, and it worked. So Friday, we do our first production test at the press conference. But everything was working seamlessly. It was a bit of a scary moment sitting next to the mayor while this is actually being tested for the first time completely. But everything turned out great, and since then, the next day was the start of this shuttle bus service. And you can still see them go around. I think I just saw one pass. But anyway, we were able to help the client on such a short time using Flutter and Firebase as well. There are a lot of things here that in a normal development process, we would say like, don't do this. And I think there's room for improvement. And we know this. One of the things is like right now, we require manual actions to update these displays. These can be replaced over time by GPS. But again, if you only have 2 weeks and you literally have 1 day to test how the GPS signals are in a historical city, we didn't want to risk that at that time. Another one is that there's a 5-second delay by if we count from the time that the driver enters the action and the screen is updated. It's okay, it works. It's only 5 seconds, we can live with that, but there's room for improvement. And there could be other stuff. We could actually have the tablets send a direct signal to the Raspberry Pi instead of going through Firestore and so on. These are all improvements that we can make along the way. And one of the most crucial things is that the drivers cannot listen to the car radio. And so what we noticed is we had people saying like, we cannot hear the spoken announcements. And I was like, okay, let's get on the bus at the bus stop right here, like debug in production. And then you just see that he's just listening to his own music. And it's like, yeah, that's something that we knew coming into this project. It was just going to be too much work to set up a whole audio system, but again, we can make that work later.
This 5 second delay, is this every time or is this up to?
It's about every time. It's quite consistent.
Any idea where the delay is coming from?
Yeah, I think it's in several places. So first of all, we have these batched events. So if I said like it takes around 2 seconds to be on our server, then there it has to go through Cloud Functions. Cloud Functions has to go to Firestore. That one has to go back to the Raspberry Pi, which also relies on the Wi-Fi connection of the same tablet. So there's a lot of possible hiccups. So if we can make this a little bit shorter, then I think we can make that better. Let me just go back to this screen actually. If we would be able to just go from here directly to the Raspberry Pi using maybe MQTT or another type of protocol, yeah, that could be resolved, I think. But again, it works for now. We can improve upon it step by step. Now, we were here. One more thing. It takes a lot of initial setup, definitely, because you have these tablets. They have to have those credentials on the hotspots. They need to have SIM cards. The Raspberry Pis need to be configured per vehicle. So those are also pain points that can be worked at in the near future. But it has a lot of advantages. One of the advantages is that we're still flexible on which platform to support. We can still switch to Linux for desktop and make this experience a bit faster if you want to step away from web-based solutions. The biggest one is definitely that we took a very pragmatic approach here. We just focused on which result we wanted to have and not specifically about, yeah, we shouldn't do this, or we just said, okay, does it work, and does it work reliable enough? And the last one, which I think is very important, for the 3 products that we built, or the 3 app products that we built for Keolis, we're using Flutter in all of them. So choosing Flutter also for this project allows us to have developers that know about the domain of Keolis and can easily switch between their different products. If we would have gone with another technology, we would have needed a different person to work there who isn't familiar with the Keolis domain. And that's all I have to say. If you have any questions, I would say shoot, I can answer them right now. If not, you can still ask me later tonight.